Welcome to long-form content of Tech Bytes and News. This is a compilation on latest news and articles featured on Hacker News. You can find the original links of articles in the description. Please like and subscribe to support future content. Hope you enjoy.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into the fascinating and somewhat controversial world of cookie-free web analytics and the surprisingly sticky question, do they actually need cookie banners? It's a legal minefield.
Exactly. I've been following this debate for a while. The core argument is that these privacy-aware analytics claim to avoid the need for those pesky cookie banners by using fingerprinting instead of cookies. But is that legally sound?
That's the million-dollar question, isn't it? The article we're discussing meticulously breaks down the legal arguments surrounding the ePrivacy Directive and GDPR. It's not just about morality. It's about compliance. The author, a non-lawyer, bravely tackles the complexities of EU law.
Right, the technical side is relatively straightforward. Traditional analytics use cookies to track users across sessions. Cookie-free analytics, on the other hand, use fingerprinting, generating a unique identifier based on user agent and IP address. Clever, but legally dubious, it seems.
Precisely. The author highlights that even this clever method might still violate the Privacy Directive. The directive prohibits accessing or processing data stored on a user's device without consent, unless it's strictly necessary for the service provided. And fingerprinting, even with anonymization, seems to fall outside that exception.
Interesting. So even though the data is anonymized, the very act of accessing the user agent and IP address information already stored on the user's device requires consent, according to the author's interpretation of the EDPB guidelines.
Yeah, that's the crux of it. The author points out that the EDPB considers the act of sending JavaScript that instructs the browser to send back information as accessing that information. It doesn't matter if you hash it afterward. The initial access is the problem. It's a pretty strict interpretation.
But wait, what about companies like Plausible and Fathom? They explicitly state that their cookie-free analytics don't require banners. Aren't they contradicting this analysis?
That's a great point. The author acknowledges this and mentions Plausible's response to his inquiry. Essentially, trust our legal team. However, the author also points out that even Plausible's later, more detailed blog post doesn't fully address the EDPB's interpretation of accessing data. It's a bit of a stalemate, really.
So it boils down to differing interpretations of the law and the lack of a definitive court ruling. Until then, it's a gamble for website owners. A risky gamble.
Exactly. The author concludes that there's no foolproof way to do web analytics without potentially violating the ePrivacy Directive. The moral high ground of privacy-preserving analytics doesn't automatically translate to legal compliance. It's a frustrating situation.
It highlights the tension between technological innovation and existing legal frameworks. The law, it seems, hasn't quite caught up with the possibilities of cookie-free analytics.
Absolutely. And the author's journey through the legal labyrinth is a testament to the complexity of this issue. Until the e-privacy regulation finally arrives, if it ever does, we're left with a lot of uncertainty. Thanks for joining us on Tech Bytes and News. Have a great day.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving deep into a fascinating article from Bits About Money, a very Chicago gamble. It's a wild ride, folks, involving casinos, complex financial structures, and some seriously questionable municipal politics. Buckle up!
A Chicago gamble? Sounds intriguing. What's the core issue here? Is it just about the casino itself, or is there something more?
Oh, it's way more than just a casino. It's about a stock offering for Bally's Chicago Casino, which has some incredibly unusual stipulations. The city of Chicago, in its host community agreement with Bally's, mandated that 25% of the equity be owned by women and minorities. But the way they're doing it, well, that's where things get messy.
Messy how? Is it illegal? Isn't that kind of discriminatory?
That's the million-dollar question, and the article doesn't definitively answer it. The application process is explicitly discriminatory, only allowing women and minorities to invest. The author points out that this might be legally problematic, given the 14th Amendment and strict scrutiny. But they also acknowledge that there's probably a legal memo somewhere justifying it. It's a fascinating ethical gray area.
So it's not just the discrimination. There's something else making it messy?
Exactly. The valuation is another huge red flag. Bally's claims the whole pie, the economic interest in the casino's future profits, is worth $1 billion. But the author argues that's completely made up. Bally's market cap is only around $1.5 billion. And that includes all their other assets. It's like they're giving away a massive chunk of the casino's value for practically nothing.
Wow, that's a bold claim. What's the author's reasoning behind that?
The author points out that if 25% is worth $250 million, the amount they're trying to raise, then the remaining 75% should be worth $750 million. But that's more than half of Bally's total market value. It suggests the $1 billion valuation is artificially inflated, possibly to make this offering seem more attractive.
So it's a sweetheart deal for select investors? And the structure is complex, right? I mean, there are multiple entities involved.
Absolutely. The capital stack is incredibly complex, involving multiple layers of companies and loans. The author even includes a diagram that looks like a spider web. It's designed to make it difficult for the average person to understand, which is probably intentional. There's also this unusual loan structure, where Bally's essentially lends investors money to buy the stock, with the loan repaid through future dividends.
That sounds incredibly risky. What are the potential downsides for investors?
Huge downsides. The author estimates that investors could easily be underwater for years, maybe even decades. The projected return on investment is incredibly long, and the risk is extremely high. Plus, there's the tax implications. Bally's is taking a position on how the loans will be taxed, but the IRS might disagree, leading to a massive tax bill down the line.
So the author is basically saying this whole thing is a bad deal, a very Chicago gamble indeed?
Precisely. The author concludes by saying they wouldn't invest, and neither should you. It's a fascinating case study in how complex financial structures can be used to obscure risk and potentially exploit less sophisticated investors. And it highlights the potential for conflicts of interest in municipal politics.
It's a cautionary tale, for sure. Thanks for breaking it down.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll see you next time. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving deep into Joel Hoxley's insightful presentation, The Past, Present, and Future of UI at GitHub. It's a fascinating look at the evolution of UI architecture at a massive scale, and the challenges they faced.
I'm really looking forward to this. The title alone suggests a compelling narrative. What were some of the key takeaways from Hoxley's talk?
Well, the core message revolves around three main lessons. First, native app experiences are setting the new standard for UI. Users expect the same level of polish and performance they get on their phones, regardless of whether they're using a website. Second, there's a real UI abstraction paradox. While design systems aim to streamline development, their adoption at scale can create unforeseen complexities. And third, front-end development is significantly more expensive than back-end, about 10 times more, according to Hoxley's experience. That's a huge difference.
10 times more? That's a staggering claim. What factors contribute to that massive cost difference?
Several things. The sheer variety of browsers, operating systems, and devices makes testing a nightmare. Browser extensions alone can introduce countless unpredictable bugs. Unlike the back end, where you often have more control over the environment, the front end is inherently more chaotic. Plus, the design process itself introduces complexities. Designs often aren't built with the constraints of the actual implementation in mind, leading to extra work for engineers to bridge the gap. It's a real disconnect.
So the design process itself is a bottleneck? That's an interesting point. I've always thought of design and engineering as separate but parallel tracks. It seems Hoxley is suggesting a more integrated approach.
Exactly. He suggests prototyping directly within the component library, rather than using tools like Figma, to minimize the translation gap. It's about aligning design and engineering from the start. This would help avoid creating designs that are difficult or impossible to implement efficiently.
That makes a lot of sense. It's like building with prefabricated components versus designing everything from scratch. But what about the UI abstraction paradox? How does that play into the high cost?
The paradox is that while design systems should simplify things, at GitHub's scale, maintaining and updating a system used thousands of times across the codebase becomes incredibly complex. Even small changes can have far-reaching consequences, requiring extensive testing and potentially causing widespread regressions. It's a classic case of Hiram's law. The more a system is used, the harder it is to change.
So they're essentially victims of their own success. That's a common problem with large-scale systems. What's Hawksley's proposed solution?
He advocates for a more cautious approach to building UI. He emphasizes the importance of reusing existing components and frameworks whenever possible, rather than constantly reinventing the wheel. He even suggests considering a global design system, rather than each company building its own. He cites Brad Frost's work on this very topic.
A global design system? That's a bold idea. It would require a significant level of collaboration across the industry, but it could potentially save a lot of time and resources in the long run.
Absolutely. And he also highlights the importance of prioritizing usability over unnecessary artistic flourishes. He uses the example of e-commerce checkouts. Why are there so many different ways to enter a shipping address? Consistency and simplicity are key to a good user experience.
That's a great point. It's all about building tools, not art. And it seems Hawksley's experience at GitHub underscores the importance of careful planning and resource allocation in front-end development. It's not just about writing code, it's about managing complexity.
Precisely. And he emphasizes the need for more robust testing methodologies for front-end code to match the rigor of back-end testing. He points out that the front-end runtime is far more varied and unpredictable than the back-end. It's a challenge that requires a different approach.
This has been a truly insightful discussion. Thanks for breaking down Hawksley's presentation for us. It's clear that UI development at scale presents unique challenges, but also opportunities for innovation and collaboration.
My pleasure. And remember, listeners, native is the new baseline. The UI abstraction paradox is real, and front-end costs 10x back-end. Budget wisely. Thanks for tuning in to Tech Bytes and News. Have a great day.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating piece from The Economist about global electricity grids. The headline says it all. To make electricity cheaper and greener, connect the world's grids. Intriguing, right?
Absolutely. It sounds revolutionary. But I'm curious, what's the core argument? Why is connecting global grids so crucial?
The main point is that currently, less than 3% of the world's electricity is traded internationally. That's a massive missed opportunity. Think about it. We could leverage renewable energy sources much more effectively. Imagine a scenario where solar power is abundant in one region, but demand is high elsewhere. Connecting the grids allows for seamless energy transfer, reducing reliance on fossil fuels, and stabilizing prices.
I see. So it's about optimizing resource allocation and boosting renewable energy adoption, right? But wouldn't there be huge logistical challenges? I mean, connecting grids across continents sounds incredibly complex.
You're absolutely right. It's a monumental undertaking. The article highlights the complexity, mentioning the recent shock in Norway where wind power fluctuations impacted electricity prices. Their neighbors were importing Norwegian hydropower, leading to price spikes and a political backlash against further exports. This illustrates the current limitations and the need for a more integrated system.
That's a great example. It shows how interconnected these issues are. But wouldn't this require massive infrastructure investments? And who would pay for it? It seems like a huge financial hurdle.
Precisely. The financial aspect is a major consideration. The article doesn't delve into specific funding mechanisms, but it implies international cooperation and potentially private investment would be necessary. It's a complex puzzle with many pieces.
And what about political hurdles? Different countries have different energy policies, priorities, and regulations. Getting everyone on board seems like a Herculean task.
You're spot on. Political will is absolutely essential. The Norwegian example perfectly illustrates the potential for national interests to clash with the broader goal of global grid integration. Negotiating agreements and overcoming political differences will be a significant challenge.
So it's not just a technical problem, but a political and economic one as well. It's a fascinating, albeit daunting, prospect. What are the potential benefits beyond cheaper and greener energy?
Well, beyond the obvious benefits, a globally interconnected grid could enhance energy security. Imagine the resilience against disruptions. A localized outage in one region wouldn't necessarily cripple the entire system. It also opens up opportunities for innovation and technological advancements in energy storage and transmission.
That's a compelling vision. It's almost utopian, but the challenges are real. The article suggests this is a long-term project, right?
Absolutely. It's not something that will happen overnight. It's a long-term vision, requiring significant investment, international collaboration, and overcoming numerous political and logistical hurdles. But the potential rewards, a cheaper, greener, and more secure global energy system, make it a goal worth striving for.
I agree. It's a bold vision, but a necessary one. Thanks for breaking down this complex topic for us.
My pleasure. And thank you for listening to Tech Bytes and News. We hope you'll join us again for our next episode. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into the fascinating world of formal proof verification using the Lean Proof Assistant, as detailed in this American Mathematical Society article. It's a real eye-opener.
I'm eager to hear this. The title, Anatomy of a Formal Proof, sounds intense. What's the core idea?
Essentially, it's a step-by-step walkthrough of proving a seemingly simple linear algebra theorem that two eigenvectors of a linear map with distinct eigenvalues are linearly independent. Within the Lean Proof Assistant, it's not just about the proof itself, but the entire process of formalization within a large collaborative project like MATLAB.
So they're not just proving the theorem, they're showing how to do it formally using a computer? That's a pretty big deal, right? What are the implications?
Huge. It highlights the power and potential of formal verification in mathematics. Think about it. A computer checks every single step, ensuring absolute rigor. This eliminates human error, a significant source of problems in complex mathematical proofs.
I see, but isn't this incredibly tedious? I mean, proving something so basic with a computer seems overkill.
That's a valid point. The article itself acknowledges that Lean often forces you to spell out arguments that are intuitively obvious. But the payoff is immense. The process reveals subtle nuances and dependencies you might miss in a traditional proof. Plus, it's all about building a robust, verifiable library of mathematics, MATLAB, that can be used for more complex proofs later on.
MATLAB, that's like a giant, collaboratively built database of verified mathematical theorems? That's incredible. How big is it?
At the time of writing, it had over 80,000 definitions and 160,000 theorems. It's a massive undertaking, maintained by hundreds of contributors using version control systems like GitHub. It's a testament to the power of collaborative mathematics in the digital age.
Wow. So how does the Lean Proof Assistant actually work? Is it just a bunch of code that checks the steps?
It's more sophisticated than that. Lean uses a system called dependent type theory. It's a type of logic where types depend on values. This allows Lean to not only check the correctness of the steps, but also ensure that the entire proof is well-formed and consistent. It's like a super-powered type checker for mathematics.
Dependent type theory. It sounds complicated. Are there any tools within Lean to help automate parts of the proof process?
Absolutely. The article discusses tactics like SIMP, which automatically simplifies expressions using a database of known equalities, and Module, which handles linear algebra manipulations. There's also ASOP, a more general-purpose automated theorem prover. These tools significantly reduce the burden of manual proof construction.
So it's not just about brute force verification. It's about leveraging automation to assist in the process. That's a clever approach. What about the generalization of the theorem? Did they just stick with the simple case?
No way. They started with the basic case of two eigenvectors, then generalized it to modules over commutative rings, and finally, to arbitrary families of eigenvectors using an injective function to represent distinct eigenvalues. This demonstrates the power of iterative refinement and generalization within the proof assistant.
That's impressive. It sounds like formal verification isn't just about checking existing proofs, but also about discovering and refining them. It's almost like a new way of doing mathematics.
Exactly. The article concludes by discussing the future of formal verification and the role of AI in assisting with the process. They even mention DeepMind's Alpha Proof, which can generate proofs at a surprisingly high level. The potential for synergy between human intuition and AI-powered automation is enormous.
This is all incredibly exciting. It seems like formal verification is poised to revolutionize how we do mathematics. It's a powerful tool for ensuring accuracy, discovering new theorems, and fostering collaboration on a global scale. Thanks for summarizing this fascinating article.
My pleasure. It's truly a remarkable development in the field. And remember, listeners, you can find the full article on the American Mathematical Society website. Until next time, goodbye from Tech Bytes and News.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into Onnit, an open-source AI chat assistant for macOS. It's really exciting stuff.
Yeah, I've been following this project. The local mode is a game changer, right? No more uploading my data to the cloud.
Exactly. That's a huge selling point. They emphasize local first, prioritizing user data privacies. It's not just about local processing. It's about giving users control over their information.
And the multi-provider support is awesome. You're not locked into a single model like OpenAI's GPT. You can switch between Anthropic's Claude, OpenAI's models, xAI's Grok, and even local models via Ollama. Incredible flexibility.
Absolutely. That provider freedom is key. It's all about choice and avoiding vendor lock-in. Plus, the file upload feature with drag-and-drop support is super convenient. Imagine the possibilities for context-rich interactions.
I'm curious about their technical details. They mention Ollama integration for local models. Is that a complex setup?
Not really. They say it's pretty straightforward. You download Ollama, and Onnit automatically detects your local models through Ollama's API. It's designed to be user-friendly, even for those less technically inclined.
That's good to hear. What about their future roadmap? Anything particularly interesting there?
Oh, definitely. They're planning some ambitious features. Auto context, which automatically pulls context from your computer, is a big one. And local RAG, for indexing and creating context from files locally, is a game changer for privacy and efficiency. They're thinking big!
Local type ahead sounds interesting too, like cursor tab, but system-wide. I wonder how that will work in practice. I'm a little skeptical about how seamless that will be across different applications.
Yeah, that's a fair point. Integrating seamlessly across various applications is a significant technical challenge. But given their progress so far, I'm optimistic. They also plan on expanding to Linux and Windows, which is great news for a wider audience.
And the licensing is pretty generous. A Creative Commons non-commercial license for V1. They're clearly committed to the open source ethos. I appreciate that.
Absolutely. Transparency and community contribution are central to their philosophy. While future versions might have paid premium features, they've promised that local chat will always remain free, and the source code will stay open. That's a strong commitment to their users.
So overall, Onnit seems like a really promising project. A powerful, privacy-focused ASI assistant with a bright future. I'm definitely going to check it out.
Me too. It's a great example of how open-source innovation can push the boundaries of AI accessibility and user control. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into Onnit. Have a great day, and we'll see you next time.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into the fascinating world of cloud virtualization, specifically exploring the internal architectures of Red Hat, AWS Firecracker, UbiCloud, and AWS Nitro. It's a complex topic, but we'll break it down step by step. Ready?
Absolutely. I've always been curious about the underlying mechanisms. So what's the core challenge this blog post addresses?
Exactly. The core challenge is the increasing complexity of understanding modern VM technology. It's not just about one component. It's a complex interplay of dozens of Linux projects working together to achieve operational and security isolation across CPU, memory, disk, and network. Think of it like a finely tuned orchestra. Each instrument, project, plays its part, but the conductor, the overall architecture, is crucial.
Right, and that's why this blog post is so valuable. It's essentially a deep dive into these architectures, right?
Precisely. They analyze 4 key reference architectures. Let's start with Red Hat. Their approach relies heavily on KVM, QEMU, and libvirt, KVM, provides the core virtualization infrastructure within the kernel, leveraging hardware virtualization features like Intel VTX or AMD. QEMU acts as both a device emulator and VMM, handling the interaction with the guest OS. And libvirt, in Red Hat's implementation, acts as a jailer, enhancing security by confining the QEMU process.
So QEMU is the key player here, emulating hardware and managing VMs. But what about isolation? How does Red Hat handle that?
Good question. Red Hat uses cgroups for operational isolation, limiting resource usage for groups of processes. For security isolation, they rely on Linux network namespaces and ccomp-BPF, though these aren't explicitly detailed in their reference architecture. Interesting, huh?
Now let's move on to AWS Firecracker. I understand it's designed for serverless workloads. What makes it different?
Firecracker takes a different approach, prioritizing lightweight design and security. While it uses KVM, it replaces QEMU with a custom VMM written in Rust. This significantly reduces overhead and attack surface. They also use Virtio for device emulation, which is a great choice for its simplicity and performance. Security is further enhanced through network namespaces and seccomp-BPF, creating a very secure sandbox for each micro VM.
So Rust's memory safety is a key advantage here, minimizing vulnerabilities. What about UbiCloud? How does their architecture compare?
UbiCloud's architecture shares similarities with Firecracker, also prioritizing security and simplicity. They use KVM and the Cloud Hypervisor, CH, which is largely based on Firecracker but offers more general-purpose capabilities. Like Firecracker, they leverage Virtio, network namespaces, and seccomp-BPF for isolation. However, they use SSH instead of REST APIs for communication between the control and data planes. A fascinating choice.
Interesting. And finally, AWS Nitro. This seems to be a more hardware-focused approach, right?
Exactly. AWS Nitro represents a significant evolution, offloading much of the virtualization workload to specialized hardware accelerators. This dramatically improves performance, especially for I/O-bound tasks. By offloading device management and VM monitoring to hardware, they reduce the reliance on a heavyweight VMM like QEMU, resulting in a more efficient and performant system. A truly impressive feat of engineering.
So in essence, we've seen a progression from software-heavy virtualization to a more hardware-accelerated approach, each with its own strengths and weaknesses. This blog post provides a really valuable comparison.
Absolutely. It highlights the evolution of cloud virtualization, the trade-offs involved in different architectural choices, and the crucial role of open-source projects in driving innovation. And remember, the blog also emphasizes the growing importance of security and the need for robust isolation mechanisms in modern cloud environments. A must-read for anyone working in this space.
Definitely. Thanks for breaking this down for us.
My pleasure. And to our listeners, thank you for joining us on Tech Bytes and News. We hope you found this discussion insightful. Have a great day, and we'll catch you next time.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into a fascinating article. Every system is a log. Avoiding coordination in distributed applications. It's all about simplifying the complexities of building resilient distributed applications. A real headache for many developers, right? Right?
Absolutely. Building distributed systems is notoriously difficult. The article highlights the constant worry about failures, concurrency issues, and the need for complex coordination mechanisms. It's a real mess, isn't it?
Exactly. The core problem is that we're dealing with multiple systems, databases, message queues, locking services, each with its own state and log. The article proposes a radical simplification, treating everything as a single log. Ingenious, huh?
So instead of coordinating multiple logs, we unify them? That sounds like a huge shift in paradigm. But how does it work in practice? I mean, databases aren't just logs, are they?
That's a great question. The article uses the analogy that databases are essentially logs. The write-ahead log is the primary source of truth. Even message queues are logs, and locking services rely on log replication. The key is to leverage this underlying log-based nature.
I see. So the proposed solution is to have a single upstream log which acts as the source of truth for all operations. Every action, every state change, is recorded as an event in this log. This includes things like acquiring and releasing locks, updating databases, and sending notifications.
Precisely. And the beauty of this approach is that it eliminates the need for complex coordination mechanisms. Concurrent invocations, retries, and failures are handled gracefully because the log maintains a complete and consistent history of events. Think of it as a single, immutable source of truth.
But wouldn't this create a massive single point of failure? And what about separation of concerns? Isn't this tightly coupling everything?
That's a valid concern. The article addresses this by suggesting that this approach isn't about replacing databases entirely. It's about using the single log for specific, scoped operations, particularly those related to state management within a service or handler. It's not about a single log for the entire system, but a strategic use within specific contexts.
Okay, that makes more sense. So it's more of a pattern than a complete architectural overhaul. The article mentions Restate, an open-source project that implements this idea. How does Restate fit into this picture?
Restate acts as the broker for this unified log, handling event delivery, retries, and ensuring exactly once semantics. It provides an SDK that simplifies the process of writing events to the log and handling retries. The SDK manages the complexities of the underlying log, making it easier for developers to build resilient applications.
So essentially, Restate abstracts away the complexities of managing the log, allowing developers to focus on business logic. That's a significant advantage. The article also mentions virtual objects in Restate. What are those?
Virtual objects in Restate are groups of stateful handlers that share state. The state is persistently stored in a key value store, and the handlers interact with it through the log. This allows for robust and consistent state management, without the need for distributed locks or complex coordination. It's a clever way to manage state within the context of the unified log.
This sounds incredibly powerful. It simplifies the development of distributed applications significantly by reducing the need for complex coordination and handling failures more gracefully. It's a compelling argument for a paradigm shift in how we think about building distributed systems.
Absolutely. The article concludes by mentioning future developments for Restate, including distributed deployments and further exploration of the log's design. It's a project worth keeping an eye on. And that's a wrap for today's Tech Bytes and News. Thanks for tuning in. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into a fascinating article, a WebAssembly compiler that fits in a tweet. It's incredibly compact, a mere 192 bytes. Can you believe it?
Whoa, 192 bytes? That's mind-blowing. I'm already intrigued. What exactly does this tiny compiler do?
It compiles arithmetic expressions written in reverse Polish notation, or RPN, into a valid WebAssembly module. The module then exports a single function that calculates the result. Think of it as a super miniaturized calculator, all within WebAssembly.
RPN, you say? That's a bit unusual. So how does this 192-byte marvel actually work? It must be heavily optimized, right?
Absolutely. The authors used a bunch of clever tricks to minimize the code size. They started by using JavaScript's assignment expression as an expression itself, cleverly reusing variables and avoiding extra statements. They also used sparse arrays, representing zeros with empty array elements.
Sparse arrays, clever. So they essentially handcrafted the WebAssembly bytecode directly?
Precisely. Instead of using a library to generate the WebAssembly, they wrote the bytes directly into an array. This is a trade-off, of course. It's less maintainable, but it drastically reduces the size. They even used single-letter variable names and reused variables to save bytes.
Wow, that's some serious optimization. But how readable is the original code? I imagine it's quite cryptic.
You're right. The original code is extremely obfuscated. The article meticulously deobfuscates it step by step, making it progressively more readable. They replace single-letter variables with descriptive names, remove assignment expressions, and add back the missing zeros from the sparse arrays.
So it's a case study in code optimization and WebAssembly internals? I see. What other tricks did they employ?
They used tagged template literals for string splitting, a ternary operator for conditional logic, and even a clever trick with index OF to generate WebAssembly opcodes. They also had a clever idea that almost worked, involving UTF-8 character codes, but it ultimately didn't pan out due to inconsistencies between character ordering and opcode values.
Fascinating. It sounds like a great learning opportunity. Did they explain the WebAssembly bytecode in detail?
Yes, they provided a commented version of the bytecode array, explaining each section: the magic number, version, type section, function section, export section, and code section. It's a great way to understand the structure of a WebAssembly module. They even discussed the limitations, such as the handling of numbers only up to 63.
Only up to 63? That's a significant limitation. But it's understandable given the size constraints. What's the overall takeaway from this article?
It's a testament to the power of optimization and a fantastic resource for learning about WebAssembly. It shows how much you can achieve with a small amount of code and a deep understanding of the underlying technology. It also highlights the trade-offs between code size and readability. If you're interested in a deeper dive into WebAssembly, the authors recommend their book, WebAssembly from the Ground Up.
Definitely sounds worth checking out. Thanks for summarizing this amazing article.
You're welcome. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll see you next time. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating approach to improving e-commerce search relevance using LLMs, even if those LLMs are, shall we say, not the sharpest tools in the shed.
Right. I'm intrigued. It sounds like a clever workaround for expensive cloud-based LLMs. What's the core idea?
Exactly. The author uses a local LLM as a kind of judge to compare pairs of products based on search queries. Think of it as a really basic, cheap way to get a lot of data on product relevance. Instead of paying for expensive human labelers or relying on costly cloud-based LLMs, he's using his laptop.
Clever. But how does a dumb LLM actually help? I mean, aren't LLMs supposed to be smart?
That's the beauty of it. He acknowledges that the individual LLM judgments are not perfect. They might say neither a lot, or even be inconsistent, but the key is that he's getting a large number of these judgments across different product attributes like name, description, and category.
So it's about quantity over quality? Interesting.
Precisely. He then uses a traditional machine learning model, a decision tree, to combine these individual, imperfect LLM judgments into a much more accurate overall assessment of product relevance. It's like a crowdsourcing approach, but with LLMs instead of humans.
I see. So the LLM acts as a feature generator for the ML model?
Exactly. The LLM generates the features, and the decision tree learns to weigh those features appropriately. The author even explores different prompting strategies for the LLM, like forcing a decision or allowing neither, and analyzes how these strategies affect the final results. He presents some pretty compelling results in tables showing precision and recall.
So what are the limitations? This sounds almost too good to be true.
Right. He himself points out that this is early-stage research. The reproducibility of the results needs further investigation, and the decision tree might overfit. He also suggests that more sophisticated ML models might yield even better results. But it's a really interesting proof of concept.
Totally. It's a great example of how we can leverage even imperfect LLMs for useful tasks by combining them with more traditional ML techniques. It's a really creative solution to a common problem in e-commerce.
Absolutely. And the fact that he's using a local LLM makes it even more appealing. It's a cost-effective and potentially scalable approach. The author even provides code on GitHub, which is fantastic for reproducibility.
Amazing! This is a really insightful approach. Thanks for breaking it down.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll catch you next time. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating urban legend surrounding a supposedly infamous quote attributed to Thomas Watson, the chairman of IBM. "I think there is a world market for maybe 5 computers." It's a quote often cited as a monumental business misjudgment. Right? Right?
Absolutely. It's a classic example of a quote that's been repeated so often, it's become accepted as fact, despite a complete lack of verifiable evidence. It's amazing how easily misinformation spreads, especially online.
Exactly. The article traces the quote's origins, and it's a wild ride. Initially, many sites attribute it to Watson in 1943, citing sources like a Microsoft slide and a PBS Nova segment. But, there's a problem.
Yeah, none of these sources actually provide a primary source for the quote. No meeting minutes, no letters, no contemporaneous accounts. It's all second-hand, third-hand, you name it.
Precisely. The article then digs deeper, uncovering an IBM historical document that suggests the quote is a misinterpretation. It seems the actual statement came from a 1953 stockholders meeting where Thomas Watson Jr. discussed the IBM 701, their first production computer.
Oh, so it wasn't a prediction about the entire market, but rather a comment about initial sales projections for a specific, very expensive machine? That's a huge difference.
A massive difference. Watson Jr. said they'd initially expected orders for 5 machines, but ended up with 18. The 5 computers part was about initial sales expectations for a single model, not a global market forecast. See? Context is everything.
I see. So the infamous quote is likely a case of telephone game gone wild, morphing a relatively accurate statement into a legendary business blunder. It highlights the dangers of accepting information at face value, especially online.
Absolutely. The article even touches on the broader issue of how much of the internet is actual history versus recreated history. This quote's persistence shows how easily myths can take root and spread, even when debunked. It's a cautionary tale for us all.
It really is. And it makes you wonder how many other facts we accept without question, simply because they're repeated often enough. We need to be more critical consumers of information.
Indeed. So the next time you encounter a seemingly definitive quote, especially one that seems too good or too bad to be true, remember the 5 computers legend. Always check the source. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into the world of tech history and urban legends. Have a great day.
Bye-bye. Thank you for listening to the daily roundup of Tech Bytes and News. See you again tomorrow. Goodbye.